Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at the setup of our P5. I've broken this into a couple of videos focusing on different topics. This video assumes that you have worked on some of the earlier projects and have particularly looked at the first video that looks at the setup, particularly dealing with the command line arguments. In this video, what we're going to do is we're going to take this setup a step further in that we are going to go ahead and collect the information from the command line that will allow for us then to go ahead and call our functions. Now, we are not going to be calling the functions themselves in this video. Instead, what we're going to do is we're going to work on capturing the input arguments from either the user or directly from the command line, depending on whether or not you have used the /i or the /p switches. So this video assumes a number of things that you have worked on some of our earlier projects. Your current P5 may be slightly different from this, but the principles will be the same. It also assumes that you've got a copy of the instructions as well as the sample file. And we're going to be using the sample file for a little bit of guidance, not only on the output, but also on the prompts for the input to the user. So let's go ahead and get started. You'll see here that I have my command line switches already triaged. And what we're going to do is we're going to start with the simplest ones, the /i's for /1d, /2d, and /beam. And essentially, I say these are simpler because what they'll do is they'll use a combination of printfs and scanfs to prompt the user for the information that we then need to pass to our functions. And so this will help us get started on the arguments that we're going to need, as well as the variables that we're going to need to support our functions. And so for the /1d/i, we prompt the user for a height and then the number of points. So from that, you can glean that you're going to need a double for the initial height and an n as an integer. So right off the bat, let's go ahead and declare a couple of variables here. We'll start off with a double y_init and an int for n. We should consider initializing both of these. However, since we are going to be leveraging a printf and a scanf, then we can have this discussion a little bit later about how and where we wish to initialize these values. Now, just a little bit of a point here. We do not intend to do any sort of interactive error checking in this particular video. And so the idea here is that the user gets one option to get their input arguments correct. And if they don't do that, and then basically what we're going to do is provide an error message back to the user without necessarily letting them change their values. We do this for a number of reasons, not the least of which is to allow for this process to be automated. If, for instance, you put a while loop in or even a do while loop that continues to prompt the user and you provided incorrect information in an automated manner, you can inadvertently hang your executable. In other words, one executable calls another. It doesn't know that it is stuck, the second executable rather is stuck inside of a loop. And so for right now, what we're going to do is we're going to give the user exactly one shot to get these values correct. We'll come back in a later video and I'll show you how to change that. So we'll go down here now to our /1d/i, and we will provide then a pair of printfs and scanfs following the sample here. In this case, it's please enter a height in feet, followed by a new line, and then the corresponding scanf with the %lf, and then the address of our y_init. Once again, this is very, very similar to our earlier projects. But the difference is we are now going to prompt the user to please enter the number of points, meaning how many calculations do we want to do, in this case, as the object is falling. And then we'll have a scanf, %lf, and the address of n. And more, let me change this real quick since we're dealing with an integer, then that's going to be %d. At this point, then we are essentially ready to call our function. As a matter of fact, I'm going to put a little note in here that we can use over and over again, ready to call our function. And once again, we're not going to do that in this video. We're going to look at how to do that in the next video. Now, for the /1d/p, we're going to do the same thing, except the source of those arguments are going to be from the command line, which means that we're going to have to convert the strings that would otherwise have been entered in on the command line into their double and their integer equivalents. And so what we'll do here is we will use the a to f and the a to I functions to convert our argv square brackets 3 and square brackets 4 into the corresponding y init and n. And to do that, we simply say y init is equal to a to f of our argv square brackets 3, and our n is going to be equal to a to I of argv square brackets 4. And then at this point, we are also ready to call our function. Now, note here, once again, we are doing no validation nor error checking on these input arguments from the command line. We would ultimately want to improve this. And once again, we will handle that in a later video. For right now, we're going to give the user essentially one chance to get this right. And if they don't, then we're simply going to provide them with some sort of feedback indicating that they've made a mistake in their arguments. We'll do the same thing now with our /2d/I. And likewise with those /1d/I. These are going to be interactive, and we have just simply more and different information to collect from the user. I encourage you to take a look at that table once again as a reminder, but basically we want to collect, in this case, our v init and our theta. That means that we need to go ahead and add a couple more variables up here. And so we'll have a double of v init and a double of our theta. And at this point, we are ready to go ahead and start first with a printf. This says, please enter a velocity, which is going to be in feet per second, followed up with a scanf, once again, utilizing a %lf, since this is a double, and we simply store that at the address of our v init. We do the same thing now for our theta. Please enter an angle. And we want to encourage the user here with telling them that it's going to be in radians, followed by a new line, and then once again, scanf, %lf, and the address of the variable theta. And then lastly, we want to go ahead and collect from the user. Again, please enter the number of points. And a scanf using %d and the address of the variable n. And at this point, we are once again ready to call our function. For the /2d/p, just like in the /1d/p, we capture that information from the additional arguments provided on the command line, namely the argv square brackets 3 through argv square brackets 5. And if you recall from the example table for the arguments, the first one is going to be the init, the second one is going to be the theta, and then the last one will be n, or the number of points that we wish to calculate. And so what we're going to do is we are going to use our a to f function one more time against our argv square brackets 3. Theta will once again leverage the a to f on our argv square brackets 4. And then lastly, a to I is going to be used on argv square brackets 5. And at this point, we're ready to call our function. And once again, we're not doing any validation before passing to the function. So if there's a problem, we're just simply going to print to the user that they entered in some incorrect information. Lastly, for the beam, we now have two pieces of information that we need to capture. W, which is essentially the load that's going to be distributed over the entire length of the beam, and L, which is going to be the length of the beam. And so what we want to do now is we want to go ahead and create two more variables, our W and our L. Once again, making the same argument about whether or not we should initialize it. And for this example, what we're going to do is we're simply going to capture the information from the user in the /beam/I, first providing them with a print statement that says, please enter the load, in this case in pounds, and a scanf %LF, and the address of the W. We have a printf again that says, please enter the length of the beam, or the beam length. This is going to be in feet, followed by a new line. And then scanf, in this case, will also be %LF. And this will simply be the address then of L. And just like in the earlier examples, particularly the interactive examples, we're going to have one more time printf, please enter the number of points with the distinction being here that these are not points in time, but rather a way of distributing the load across the beam. In other words, how many applications of W are going to be on L. And we have a scanf, once again, of a %D, followed by the address of N. And at this point, we are, once again, ready to call our function. And then lastly, we want to do the same thing now with the parametric option, where we simply capture the additional arguments from the command line and store them in their appropriate variables. And so we'll start off with W. We're going to use the A to F function, and we're going to apply that to our argv square brackets 3. We have L applied to, or rather our A to F applied to argv square brackets 4 for our L, and then N is going to be A to I for argv square brackets 5. Now, please note, if you accidentally use A to F or A to I for the wrong variable, you'll get some unpredictable results, bizarre behavior to say the least, because you're going to be attempting to store, or you'll either attempt to store the value incorrectly, or you end up truncating a value depending on which combination you use. But ultimately, at this point, we are once again ready to call our function. We're going to do no pre-validation here either. We're going to allow for the functions to handle that themselves. And so at this point, we've successfully set up our P5. In the next video, what we'll do is we'll take a look at the variables that are going to be needed to pass by reference to our functions. But as always, hopefully you found this video useful. If you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.